In this video, I'm going to give you an example of how to sketch a secant function. To start, I'm going to consider what its reciprocal function would be. Y equals 2 cosine pi over 4 x plus 3. Now I'm going to make my cue list. A, B, P, I, D, X, X sub 2, X sub 3, X sub 4, and X sub 5. A is the absolute value of the coefficient that precedes the trig function, in this case 2. B is the coefficient that precedes the x, which in this case is pi over 4. The formula for period is 2 pi over b. So in this case, it's going to be 2 pi over 4. Dividing by a fraction is the same as multiplying by the reciprocal. So that's going to be 2 pi times 4 over pi. The pi's cancel out and it leaves you with 8. The increment is the period divided by 4. If we take the period and we divide it by 4, 8 over 4 leaves us with 2. The midline here is the number that comes at the end. In this case, it's 0. To find the first key point, what you're going to do is set the parentheses equal to 0. I should say set the expression inside the parentheses equal to 0. X plus 3 is equal to 0, which means that x equals negative 3. This is going to be our starting point. We started at negative 3 and we advanced by 2 to get to successive key points. So the next key point is going to be at negative 1. If we add 2 again, we're going to be at 1, and then 3, and then 5. So from here to here, we're adding 2. From here to here, we're adding 2. And we just keep doing the same thing to travel from key point to key point. We're advancing by what's called the increment. Now I want to choose a scale so that this is going to look good and not look smushed on the page. This takes a little bit of planning, but it's certainly part of the process. So I'm going to start by making an x-axis, and I'm going to put that right here. Okay, now I need to place the y-axis, but I need to realize that there's going to be certain elements that are to the left of the y-axis and a few more elements that are going to be on the right. So I think I'm going to put it somewhere right here. Okay, let me label the axes. So this is y, this is x. Okay, so I'm going to go up 2 as dictated by the a value or the amplitude, and down negative 2. And now I've got a decision to make. If I let every box be 1 unit, my first key point's at negative 3, so that's 1, 2, negative 3. And then it would end at 5, which would be 1, 2, 3, 4, 5. So it would start here and it would end about here. Now if I let every 2 boxes equal 1 unit, then it would be negative 1, negative 2, negative 3, and then 1, 2, 3, 4, 5. I could do that also. That would be really spread out. And sometimes that's nice to keep it nice and spread out. So I think I'm going to go that route. It's better to be too spread out than to be too smushed. You want it to be pretty easy to read. But you also don't want to go off the page. So it requires a little bit of planning. So this is going to be negative 3, negative 2, negative 1, 1, 2, 3, 4, 5. I'm going to start by sketching what I call the helper graph, which is this one, and I'm going to do that in red. It's a cosine, and the midline happens to be right on top of the x-axis because it's at 0. So if I really had to, I could put that in here. I guess I'll do that just so there's no confusion. Okay. In my class, the way that I remember the basic shape of cosine is the mnemonic mimim. max, intercept, min, intercept, max. My first key point is at -3, and it's a max. The second key point is at -1, and it's an intercept. The third key point is at +1, and it's a min. The fourth key point is at 3, and it's an intercept. And the fifth key point is at 5, and it's a max. This is my helper graph. It's going to be a cosine, and I'm going to make it dotted because it's not the star of the show. It's just playing a supporting role. It's just going to help me make this secant graph. Wow, that's really not very good, but it's all right. It's good enough. Actually, it's not too bad. Now, when we studied the basic shape of secant, we said that there is going to be a vertical asymptote at both the second and fourth key points. Well, here's the second point, so I'll put a vertical asymptote there. And here's the fourth point, and I'll put a vertical asymptote there. Now, like the cosecant graph, we have a smile and a frown and a smile and a frown, etc., except we have half smiles in this one. We have a full frown, which looks like a upside-down parabola-ish looking thing. And then from here we'll have half a parabola going up, and here we'll have the other half. Now, if we kept going, and I'll do this in a lighter color to show that this is one cycle, but if I kept going, you'd see more of this over here. There would be your other smile. And if you kept going more on this side, there would be your other smile. But we're only asked to graph one cycle, so that's going to be sufficient. Okay, so there's your graph of 2 secant pi over 4 x plus 3. Let's take a moment and consider the domain and the range. I think the range is going to be easy. It's your y values scanned from bottom to top. The graph points straight down, which is -infinity, and then it climbs to a value of -2. Then there's a break between -2 and 2, and then it picks up again at 2, and it goes to infinity. The domain's a little bit more challenging. The domain, for starters, we could say exists all reals except, and there are exceptions, and the exceptions are going to be where the asymptotes are. So we'll say except at x equals, and we'll name the first asymptote we see. The first asymptote we see is at -1. Now, how far are other asymptotes away from this first one? Well, it looks to me that if I'm at -1 and my next one's at 3, it looks like I've gone up 4 units. If I wanted to draw another asymptote to the left of this starting point, I would have to go 4 units in this direction, and there'd be another one. So I could go up by 4, or I can go down by 4. And I can do it as many times as I want because the graph goes on and on. So I could go up by 4, put an asymptote. I can go up by 4 again, put another asymptote. I can go up by 4 again. So what I'm going to say is plus 4n such that n is an element of the integers. This symbol means is an element of, and the z means integers. So an integer could be 0. 0 times 4 is 0, so that means one of your asymptotes is going to be at -1, and there is. But if I let n equal 1, that becomes 1 times 4, which is 4. -1 plus 4 is 3, and that's where the next one is. So if we added 2 cycles of 4 on, that's going to be 8, minus 1 is 7, and that's where your next one would be. And you could also add, or let n equal negative numbers, and that would allow for asymptotes to the left.